Alrighty, guys. Good morning, good afternoon, good evening. Whenever you are watching this video, by that time, it should be either morning, afternoon, or evening. Alright. Today's lesson, we're going to cover molar mass. In my last videos, we briefly introduced the concept of the mole, and then in my my previous video, we talked about how to apply that mole and using it to determine the amount of atoms within a given compound. We're going to take this step a little further and now add on to that with the molar mass. All right, before we do any examples, let's talk about the theoretical part of it really quick. All right, so up top it says the mass, which we're going to use grams because remember grams are SI units. The mass of 1 mole of an element. The mass of 1 mole of an element. So anytime that we talk about molar mass, we're referring to the mass in grams of 1 mole of any element. All right. The atomic mass of an element expressed in grams is the mass of a mole of that element. That is saying that when we look at a periodic table and we figure out or we discover the atomic mass of a specific atom, that numerical value stresses the molar mass of that atom. All right. So let's look at some examples. All right. So for example, carbon. On the periodic table, carbon looks like the following. It has a 6 up top, a C, and then at the bottom 12.01. All right, we know that 6 is the atomic number, and we know C is the 1-letter abbreviation, and that at the bottom it's the atomic mass. All right, we've learned about atomic mass in the first couple of months of school. All right, that's the atomic mass. That's grams per mole, or AMUs. We can also use that atomic mass. And now instead of calling it the atomic mass, we can say that is the molar mass. That numerical value is the mass of 1 mole of carbon. And remember that 1 mole of carbon equals Avogadro's number. 1 mole of carbon equals 6.02 times 10 to the 23rd atoms. That means this amount of carbon atoms, has the mass of 12.01 grams. All right, so again, we use the atomic mass to decipher the molar mass. The atomic mass has the same numerical value as the molar mass. All right, let's look at another example, chlorine. All right, chlorine, 17 up top, CO, and then at the bottom, 35.45. 17 is the atomic number. At the bottom is the atomic mass. All right, the atomic mass, again, remember, it can also refer to the molar mass. So 1 mole of chlorine, remember, anytime we talk about a mole, that mole is going to equal Avogadro's number. 1 mole of carbon is equal to Avogadro's number. 1 mole of chlorine is equal to Avogadro's number. 1 mole of tungsten is equal to Avogadro's number. It's all the same. So 1 mole of chlorine is equal to 6.02 times 10 to the 23rd atoms. But the mass of these atoms is going to be greater, 35.45. All right, so the mass of 6.02 times 10 to the 23rd atoms of chlorine is going to be 35.45. And this value, again, you can find on the periodic table. It's the atomic mass, but we're using it for the molar mass. All right. All right, let's take it a little farther. So like I said, notice that in my previous example, 12.01 grams of carbon contains the same number of atoms as 35.45 grams of chlorine. All right, they both have 6.02 times 10 to the 23rd atoms. All right. The only thing is the molar masses of any two elements must contain the same number of atoms, but they have different masses. All right. Every molar mass of all elements equals a mole of that given element, all right, which is ultimately Avogadro's number. And all that's saying is that anytime we talk about a mole of a specific atom, it's referring to 6.02 times 10 to the 23rd atoms. All right. And I guess, the big question is, why do different elements have the same number of atoms in a mole but have different masses for their mole? All right, in the comments, I want you to give your best explanation, and whoever gets the explanation right will receive extra credit. All right, so I want you to answer, why do different elements have the same number of atoms in a mole but have different masses? All right, for an example, chlorine and carbon, they both, a mole of chlorine is equal to 6.02 times 10 to the 23rd. And the same thing is true for carbon. 1 mole is equal to 6.02 times 10 to the 23rd atoms. All right, each one is referring to atoms. Why is it then on the periodic table does this amount of chlorine atoms has a larger mass than this amount of carbon atoms? That's the question. All right, answer that in the comments and you will receive extra credit if you get it right. In addition to that, say something funny. All right, make me laugh. All right, I want to, have a good time as well as reading these extra credit. So answer that question. If you get it right, you get extra credit. And just to make a fun time out of it, say something funny. I don't know, whatever it is. All right. All right, let's do now a practical example where we are trying to figure out the molar mass of a compound. All right, we want to figure out what is the molar mass of a compound. This is one of the easiest things that we're going to do in chemistry. All right, so let's start off with an example. We have sulfur trioxide, SO3. The first thing you're going to do is you have to realize that whichever compound I give you, you have to know the chemical formula. In this case, SO3. The second thing you need to realize is that sulfur trioxide has 1 sulfur and 3 oxygens. All right, notice that in the chemical formula, there's only 1 sulfur, and that 3 represents 3 oxygens. 1 sulfur, 3 oxygens, SO3. All right, number 2, you're going to go on the periodic table and you're going to individually find out the atomic masses or the molar masses for each individual atom. Sulfur has a molar mass of 32.1 AMU. Oxygen has a molar mass of 16.00 AMU. All right, you can either call them atomic mass or molar mass. They're the same thing at this point. All right, so we know that you can get these from the periodic table. Very, very simple. The next thing you're going to do is you're going to recall that we have 1 sulfur and 3 oxygens. So if each sulfur has an atomic mass of 32.1 AMU, we just keep it as 1 times that amount because we only have 1 sulfur. Since we have 3 oxygens, we're going to multiply the atomic mass by 3 because we have 3 oxygens in sulfur trioxide. All right, you're going to do the multiplication and then add them to get 80.1 AMU. That is the molar mass of SO3. All right, that is the molar mass. And notice we still have those units of AMU. We only use the units AMU when talking about atomic mass. These are atomic mass units. But since we're talking about molar mass, instead of AMU, it's going to be grams per mole. All right, if I see an answer with AMU when talking about the molar mass of a compound, you will get it wrong. The units for molar mass are grams per mole because this is the mass in grams for 1 mole of SO3. All right, 80.1 AMU is equal to 80.1 grams per mole. That's the amount of grams that this SO3, the mass in grams per mole. All right. You can also make the following statement. 1 mole of SO3 has a mass of 80.1 grams. This is the mass of 6.02 times 10 to the 23rd molecules of SO3. All right, very, very technical stuff, but very simple. All right, I'm going to do one more example, and then I will let you guys go. Let's assume that this is a quiz, and I'm asking you, hey, calculate the molar mass of HN2O3. The first step you want to do is you want to break this bad boy down, or this little girl down. All right, step 1. Realize that we have 1 hydrogen. All right, and we have 2 nitrogens. And we have 3 oxygens. And when we add all those values up, we should have the molar mass of H N2O3. Yay, my pen's dying. Alright. So let me just charge my pen for a little bit. Boop. Beep. Alright. That's the molar mass. The second thing we want to do is we're going to go to our handy dandy periodic table. Our handy dandy periodic table. And we're going to figure out, or we're going to locate the atomic mass for each one of these atoms. The first one we have is hydrogen. So let's go to our handy dandy periodic table. Hydrogen has an atomic mass of 1.008. All right, awesome. Now we're going to look for the atomic mass for nitrogen. Nitrogen has an atomic mass of 14.007. For sure. Awesome. Sweet. Got it. And finally, oxygen, which is all, well, actually, yeah, oxygen. Oxygen has an atomic mass of 15.9999, that's 16.00. You can keep as the atomic mass. All right. Those are the atomic masses. So we're going to now incorporate those values. So it's going to be 1 times 1.008 plus 2 times nitrogen's atomic mass, 14.007, and plus our handy dandy oxygen, kinamasiki. That's how you say oxygen in Latin. That's just a joke. Alright, so we have 3 oxygens. Again, we're going to have a 16.00 because who cares about all those 9s? Alright, that is going to give us some value. Let's see if I have the answer, because if I don't, I really am going to be annoyed with myself. I don't have the answer. Nice. Alright, so let me just do this really quick on my phone. Actually, I'm not going to do it. Alright, this is going to give you some value. Crap. Okay. So this is going to be obviously 1. Let's just say 1 plus 14 times 2 is 28. Plus 3 times 16, 16 plus 16 is going to be 32. 32 plus 16 is 48. I hope I did that right. 6, 12, 18. Yeah, I did that right. All right, those are just approximate values. That's going to give us, what is that? 8 plus 8 is 16. Sorry, 8 plus 8 is 16. 16, 26, 36. 76, 78, maybe 78. 8, 16. I'm tripping. 4, 5, 6, 7. Okay, I just missed one. All right. That is going to give us a value of 77 AMU. All right. Step 3, we're going to take those AMUs and take those bad boys off, because we are talking about molar mass. Molar mass, these units are grams per mole. That is our answer. This stuff is really easy, guys. All right. I will put your practice problems online. Other than that, we out. So if you've noticed, I need a haircut. My haircut's super long. And I have not been putting product in it because I've been extremely lazy. And that's another reason why I've been wearing a lot of caps. All right. Peace. Love you guys. Miss you all. Leave a comment. I love hearing from you guys. And trust me, it's literally because I have a genuine interest in what you guys are doing. All right. God bless you guys, and see you later. Peace.